So in situ heat testing,
Yep.
and obviously there's a standard there, a UL 1598. Sorry. What are we doing there?
Basically, they're testing the heat of the fixture with the chip and driver and everything in place to check, I guess, that the ambient of the fitting is not exceeding chip ambient and things like that, to make sure that if we're saying that you're going to get 50,000 hours life based on an ambient range of minus this to plus that, then that's what you're going to get because it's been tested.
It's been tested in that case. It has a little bit to do with heatsink, would you
say?
Yeah,
absolutely. So every LED fitting has a heatsink. I'm just going to use this Knox fitting that's sitting here. So on the back of that fitting, it's got a heatsink. So this dissipates the heat. That helps maintain the life of the chip. If you don't have a good quality heatsink, then your chip could overheat. And you know, if someone says that you're getting 50,000 hours and then in 10,000 hours it's failed, it's probably because it hasn't got a good heatsink and the heat's not getting away.
Look, it's interesting you talk about heat and LEDs, because as the technical support for Emelec, I get a lot of people saying, you know, no, LEDs are not hot, they don't get hot. LED strip, for example, doesn't get hot. It doesn't emit a heat, you know. But it's interesting looking at this because it does prove that LEDs do get hot.
Absolutely.
So we do have to take into consideration the ability of putting them in a ceiling with insulation and things like that, the covering over and all of that.
Yeah. The heat comes at the back, through the back of the chip, and therefore that's where the heatsink is always mounted behind the chips to alleviate the heat.
Right.
And strip in particular, if they don't put strip into some sort of channel or something like that, if they just mount it onto timber, the heat's got nowhere to go.
Yes.
So you know, you'll start seeing little patches of strip fail because it's just overheating. It's
overheating itself. Yeah. So it's always a good rule of thumb to put anything LED on something that can act as a heat sink.
Absolutely.
So it can dissipate the heat.
Absolutely.
That's a very interesting point. Okay, so this is the life prediction. So this is the curve that they work off with those formulas that we were looking at previously.
So you see there, what they've done is they've done it to 6,000 hours, and then they've extrapolated what it's going to look like if it's maintaining the same curve over a period up to 71,000 hours, it looks like there. So, you know, if you were working on a design and we said we were going to give you 50,000 hours, then we could look at that chart and determine approximately what lumen output you're going to have at that 70,000, at that 50,000 hours.
We've actually had a lot of government departments actually asking for a chart similar to that.
Yep.
Is that because they put that into their maintenance programs?
They probably put it in their maintenance program, saying, you know, they want a fitting that gives you this much light at the end of life.
Yes.
So that they know that it's time to change it, and they haven't gone below their required levels that they've had.
Okay, so that's what it's got to do with. It's got to do with their going below the required light levels at a desk or an office or a laboratory or something like that.
Yep.
So there's a lot more to designing a building, a shed or something like that than what we normally think of. So Robin, we've got IES TM21.
Yep.
We've got the measurement of estimation of LED lumen depreciation, but can you elaborate on that a little bit?
What the TM21 does, it takes the manufacturer's data at the 6,000 hour mark, and it then extrapolates it and projects the lumen maintenance over the period of time. So, and that's given as a TM21 result. So, it's all about the chip depreciation.
Excellent. Okay. So again, that's done in the laboratory. That's not something that would be done
out on site. No,
that's good.